And action, GCF. So what we're going to look at as we're doing the GCF is prime factorization. So that's a word that we need to know what it means. So prime factorization is the factors, sorry, the number written as a product of prime factors. For example, if we have 2 times 3 times 5, that would equal what number? 30. So 2 times 3 times 5 is an example of prime factorization of 30. Okay. So it's going to be a product, which is a multiplication statement of those numbers. Okay, it's a multiplication statement. Now, what kind of order is 2, 3, and 5 written in? Yeah, Jimmy?
Smallest to largest.
Smallest to largest. It is not 3 times 2 times 5. No, that's not mathematical. There's no thinking involved there. It's barf on the page. All right, I don't want that. So put it in order, please. We usually like to go low to small. Now, instead of writing, say we had 2 times 2 times 3 times 3 times 3 times 5, what would be the shortcut method? Yep. 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 Exactly. 2 squared times 3 cubed times 5. So we do want to use our exponents where possible. Is 2 a prime number? Yes. Is 3 a prime number? Yes. 5? Yes. What's after that? 2, 3, 5, 7. Starts getting harder now. 11, 13, then what? 17. No, not 20. There's one before it. 19. 20? No. 2 times 10. What's 20? 23. Then 29. 31. Okay, now the numbers that we're going to be dealing with are 2, 3, 5, 7, 11, sometimes 13. Those are the bread and butter, 2, 3, 5, 7. Okay? Those are the bread and butter. So did you write those down on top? I hope so. Right? Gives you some ideas, some prime numbers to try. Especially when you have a calculator with the hard ones, right? Did you write those down? Okay, so how do we get these prime factors? Well, let's write the prime factorization of 72. So I'm going to show you 2 different methods. First of all, the factor tree. So you did this one long ago. What 2 numbers multiply to 72? 36 and 2. That's a harder one. Okay. What about, there's a few different answers here. What about 6 and 12? Okay, 6 and 12. So that's the hardest step, figuring those ones out. So you're going to have to guess and check. What about 6? What does that split into? Yeah, see, now we're way easier, right? 12? Yep. Or what else could you have said? 2 and 6. It doesn't really matter, right? There's different options here. But once you get to the roots of the factor tree, they'll be the same. So 4 splits into 2 and 2. Now, if you're an expert, you could see them. But back when you were a little kitty, they always said carry down the prime factors so you can see them all at the same level. Okay? So we can say 72 equals 2 exponent what? 3, there's 3 of them, times 2 to the exponent, sorry, pardon me, times 3. Wow, 3 to the exponent 2. Okay, there we go. There's our answer. Which one is the smaller base? The 2. Okay, we don't look at the exponents to see which goes first. We look at the base to see which goes first. Okay, the base here is a 2, and the next base is a 3. Okay, we do not look at the exponents to decide that. Okay. Any questions? A lot of people can do that method. It's a pretty good method. Now there's also what we call a factor ladder. It's kind of a cheating way. So 72, big number. It ends in what? An even number. So what can we divide by? 2. Okay. What if it ends in a 0 or a 5? What can we divide by? Divide by 5. What about if the digits add? What does 7 and 2 add to? 7 plus 2 equals 9. So if the digits add to a number divisible by 3, then you can divide by 3. So for example, 7 plus 2 equals 9, which you can divide by 3. So then we can go 72 divided by 3. Okay. That one's helpful, I find, so I always kind of bring it up. Okay. Any questions about that? Now, I could start with a 3 if I wanted to, but I don't feel like it. So let's see. 7 divided by 2 is 3, and that would be with 1 left over. So then we have 12 divided by 2 is 6. See how we're doing that? Okay, so 7 divided by 2 is a 3, remainder is a 1, then we get 12. 12 divided by 2 is 6. So we have an even number. What can we divide by? 2. 3 divided by 2 is 1. What would be the remainder?
1.
1. Okay. 16 divided by 2 is 8. Okay, how you guys doing with this? Not bad. Gets a little weird sometimes though. 18. Sure, divide by 2 again. What do we have? 9. Is 9 prime? No. Sometimes we think it is, but it's not. Which we divide by? 3. And 3 is left over, so it's down below. Okay, or 9 divided by 3 is 3. So what does 72 equal as a prime factorization? 2 to the exponent times 3 to the exponent 2. Okay, that's your answer. How is that? Easy? Not bad? Okay, try 88 and 120. For 88, you guys want a hint? 11. Okay. Go ahead, try those two, please. Go. That stands for greatest common factor. Now it's a factor. So factors are smaller than what you start with. That's really important. Okay? Factors are smaller. So you're not looking for something larger than 15 or 21. You're looking for something smaller than 15 or 21. Okay? So, old school method, 15 and 21. Let me show you two. The old school would be, never mind. First of all, we're going to do the factors. I really like this method, 15 and 21. What number can you divide them both by? 3. Divide by 3, and you get 5 and 7. Can you divide 5 and 7 by the same number? No. So there's no more common factors. So your GCF is very simply 3. Okay. Now let's try something like, this is a really simple question, so let's try something a little bit harder like, 16 and 32. Okay, 16 and 32. What can we divide them both by? Has to be prime though. 2. And we get 8 and 16. Just a second. Right here. Okay. Just grab a package that's right there on the table. Yeah, and grab the one right beside it. Okay, and grab a seat beside green shirt, and he can help you out. Okay. Okay, divide it both by 2, and we get 4 and 8. Divide by 2, we get 2 and 4. Divide by 2, and we get 1 and 2. So for this example, these numbers are your GCF on the side. We ignore the bottom. So your GCF equals 2 to the exponent 4, which equals what? 16 for this question. Okay? 2 times 2 times 2 times 2. So where do we find our GCF? Over on the side. Okay? Good. Now, we can also do prime factorization. So let's go 52, do them separately, divide by 2. And you're going to get 26. Divide by 2, you get 13. Okay. Do the same thing for 78. Okay. So divide by 2, we get 39. Divide by 3. Right? 9 plus 3 is 12, so you can divide by 3. Because 12 is divisible by 3. You get 13. Okay. So what here would be the prime factors? Well, we have a 2 and a 13 that are common. Right? So these here are common factors. So the GCF equals 2 times 13. Now if we line them up, we can say 52 equals 2 squared times 13. And this is where it gets a little murky, so some of you might just want to shut off your ears. 2 times 3 equals 13. Okay, so we would pick the lowest exponent. Right? So we have this here and this here. Okay, now that gets a little bit murky for some of you, so just ignore it. You don't need to look at it that way. I like this method right here. This is the method, the most and the easiest one. Okay? So some of you just might want to look what I just highlighted, circled in green, and just leave it at that. And that's the method we're going to do for the next question. Okay? The one I just circled. So let's have 18 and 24. I want you to go ahead, find the GCF. Go. Just real quickly, 18 and 24. Choose prime numbers, please. Divide by 2, we get 9 and 12. Divide by 3, we get 3 and 4. So what's the GCF? Right here. GCF equals 2 times 3. Okay, this is a product of primes. You might see this in your textbook. If they say write the GCF as a product of prime factors, they want the 2 times the 3. But most of you realize, well, that's 6. Okay, but what they're referring to is right as the factors. Okay. How many people got that? Hands up. Awesome. Okay, how many people have done the next one? Hands up. Couple. Okay, I'll give you one more quick minute. Okay, 72 and 84. For B, how many people got 12? Hands up. Good. Okay. Now again, I make mistakes all over the place, so if I make a mistake, let me know. I sometimes get wrong answers, as many of you know that have had me before. So don't hesitate to call it out. Yeah, question? You know what? I'm always in the habit of showing both, and because then I wouldn't mark it wrong. It's kind of a trick, right? Whatever I ask for, you're going to have the right answer. Okay. Yeah. Yeah, totally. Absolutely. It doesn't matter which order you do it in, but you don't want to do this. You don't want to divide something by 12 or only one of them, right? Like, you've got to be able to divide them both. Okay, now you're going to see what I'm talking about with the LCM, because we actually do that a little bit different. Okay. Any other questions? Okay, turn over. So the LCM stands for the lowest or least common multiple. And the key vocabulary word there is multiple, because multiples are larger than the starting numbers. Okay, so for example, list the multiples of 5, 8, and 10. Multiples of 5 would be 5, 10, 15. You can call out if you want. Or not. Thanks for making this so much fun. The next, you can use 8. What are multiples of 8? 8. 6. Good. 10. Good. 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 One more. Awesome. Now multiples of 10, this is a hard one. That's sarcasm, yes. 10, 20, 80? No. 700? No. Okay, good. So 10, 20, 30, 40, 50. So that's what multiples are, right? And then which one's the lowest? Well, yeah, 40. Sticks out like a sore thumb. Now that's easy with these cooked up special numbers. But of course, are we going to give you those easy numbers? No, we're math teachers. We're mean. Okay, so 10, 15, 25. Getting a little bit harder there. So what we do here is we can, actually, sorry, let's go back here. 5, 8, and 10. We can divide all those, well, some of them by 5. Not all of them, just some of them. So we can get 1, 8, and 5. Okay. And so 8 and 5, can you divide them by a number? No. So your LCM makes the letter L. Notice this is not a GCF. We didn't divide them all by the number 5. Only 2 of them. And this isn't a 5. You guys, I just said I make mistakes, and you guys are sitting there not saying anything. What's 10 divided by 5? Thank you. Can we keep going now? What about 8 and 2? Can we divide them by the same number? Yes. So we can go 1, 4, and 1. So now the LCM. And you gotta be careful with this one, because what does 4 become? Yeah, 2 times 2, right? So this is a bad example, Mr. Barker. Shame, shame. 2 cubed times 5. What is that? 2 times 2 is 4, times 2 is 8, times 5 is 40. Yeah, we found that up top, right? Okay. So that's kind of a weird example, isn't it? A little bit different. What shape does the LCM make? The letter L. Okay, don't forget to include the numbers below. This isn't always going to be your GCF now, so be aware of that. So let's try this. 10, 15, and 25. Okay. What can we divide them all by? Yay! We had 2, 3, and 5. Can we do anything else? No. So what is our LCM as a product of primes? 2 times 3 times 5 squared. Okay, that's getting close to a calculator question, but it's not. Because 2 times 3 is 6. 5 squared is 25. Sorry? No, not adding, though. It's multiplication. Yeah, so it's multiplication still. 6 times 25. 6 quarters. Yeah, notice how as soon as I say 6 quarters, you're like, oh, I know that, $1.50, so it's 150. Okay? Money can sometimes help you with your multiplying, so sometimes use it. Okay? All right. How you guys doing so far? Okay, good. Let's try this one. 28, 42, and 63. There is a prime factor. Hmm, 4, 6, and 9. Can you divide all 3 by the same number? No. So this is what I like to do, and you guys should do this as well. I make a mark. Beep, 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 beep. Why did I make that mark? Well, what's below 7? Is it a common number we're going to be dividing by?
No.
No. So what happens is your GCF stops. Your GCF now is no longer, so our GCF simply equals 7. Sometimes we'll get 2 or 3 numbers in there, and then we're out of common factors. So whenever you stop your common factors, I always make a line just so that I'm careful and don't screw up. What number should we divide by now? Pick one.
3.
Awesome. This one cannot change, so we keep 4 as 4. These two, yes, we divide. Okay. Now what should we do? Divide by? Yeah, divide by 2. Let's go for that. So we have 2, a 1, and a 3. So now, what is my LCM? Times 3 squared times 7. So it'd be 4 times 9 times 7. What's that? 252? Yeah, that looks right. Good. Make sure you have both parts, folks, because I do ask for both. Okay, so you have the product of primes, which is 2 squared times 3 squared times 7, and then the 252. All right. I want you to try next one on your own. 12, 24, 30, 72. I know some people are still finishing up. Here's my work. I stopped for my GCF and put my line there, and then continued on because there was a couple common numbers, but not common with all the numbers. Okay, so I could do some more divisions, but it wasn't common with all of them. So then my LCM would be 2 cubed times 3 squared times 5. So that'd be 8, no, 2 times 2 is 4, yeah, 8 times 9 times 5. 360? I'm just double checking. Yeah, 360. Okay. So that's pushing, like that's kind of on the upper limits of a non-calculator question. All right. Thumbs up, down in the middle. Where are you guys at? All right. Now your homework, we're going to start some easier questions and then get a little more complicated. We're going to kind of whiz through these. Working with fractions, 28 and 98. Basically, when it says simplify, it means to reduce to lowest terms. So what we do is we divide by the GCF. That's a horrible question. Let's say I had something like 28 over 42. Okay. Now 28 and 42, I think the GCF is 7 there. So if I divide this by 7, that equals 4. If I divide the bottom by 7, that equals 6. Is that the GCF then? No, because I'm not in lowest terms. So I think the GCF then I'd multiply by 2 to get 14. And so 28 divided by 14 is 2. 42 divided by 14, oh Lord help me, 3? Yeah, 3. So this here is your GCF. All right. Next one, evaluate. Because you're adding, subtracting, what do you need for a fraction? Common denominator. So 5, 12, and 3. This is a bigger one. I'm going to go quick. What's the common denominator with those ones? I think it's 60. Okay. So how do I go from 5 to 60? Times by 12. And so I would get 36 over 60. The next one, I multiply by 5 to get 60. So I get 25 over 60. And the very last one, I multiply by 20. And it's not so much what you multiply by, it's more what's the common denominator. Okay. Now that I have a common denominator, LCM, I can now add or subtract. Okay. So that's LCM application. Any questions with those? Why we do them, how we do them? You've done this for a while. Right? This is a harder question, right? This again is probably pushing the non-calculator stuff. Okay, next one. Maria wants to cut 2 pieces of material into equal size squares. So there's 2 pieces, underlining the word 2. One is 12 by 36 and the other is 6 by 42. So let's draw a diagram. One is 12 by 36, so it's a rectangle. The other one is 6 by 42, also a rectangle. So she wants to cut both of them into equal pieces, equal size squares. So what's the largest size square? That would be the GCF. So can you look at those numbers and see the GCF? 6, 12, 36, 42. Those are all multiples of 6. Okay. Now you don't have to do that. You go 6, 12, 36, and 42. Divide them all by 2. And then divide them all by 3. And so then you can see the GCF is 2 times 3, which is 6. Okay. So the diagram is really helpful there. So then you can see you have 2 pieces. You want to cut them into smaller squares, but the largest one. Because you could have done squares of 2 by 2. You could have done squares of 3 by 3, but 6 by 6 is the largest. Okay. Any questions? Okay, Jed and Jethro, they're stacking pails. Jed, 24 at a time. So 24, 48, etc. Jethro's 40 pails at a time. So 40, 80, 120. What's the least amount of pails when they are stacked to the same height? So now we're finding the LCM. So 24 and 40. Go ahead, find the LCM. Go. So 120. So there would be 120 pails. Hands up if you got that. We're working towards that. Perfect. So just to recap, your GCF, you're looking for a factor, which is a smaller number. For the LCM, you're looking for a multiple, and that's a larger number. Keeping that in mind, that can help you look for the right answer. Okay, get you on the right track. Okay. So, for your homework, Belle's going to go in get about 5 minutes. If you look at your outline, okay, today's work has a worksheet as well, finding the GCF and LCM. That's the next page, front and back. Okay. Once you start cruising, you'll go pretty quick. We're not going to do the textbook. We'll do that tomorrow in class. Okay. As well, don't forget you need the course outline signed. So there's your homework. You can write in your agenda if you want. Course outline signed, that's the last page. And the worksheet should be the GCF and the LCM. Now.